This video is sponsored by Omaze. Research into sodium-ion batteries has been gathering pace in the last decade, and that should surprise no one. Lithium-ion batteries are unmatched in their performance. But the high cost of materials, along with their environmental impact, means that there is a niche in the market for something that may be slightly lower performance, but addresses some of the environmental and supply chain issues that plague lithium-ion batteries. Enter sodium-ion batteries. First explored in the 1980s, before the arrival and subsequent domination of the lithium-ion, they were successfully tested. There were also a few prototype electric cars, but they could not compete with Sony's lithium-ion batteries or become mainstream. Apart from the high temperature, you also couldn't use a graphite anode, since the sodium ion was too large to fit between the interstices. But recent scientific breakthroughs, as well as cheap renewables, driving demand for safe, cheap, environmentally friendly energy storage, have resulted in the renewed interest in sodium-ion batteries. Before we discuss the various advantages and disadvantages of this technology, let's quickly understand how it works. You'll be happy to know that sodium-ion batteries are relatively easier to understand if you already understand lithium-ion batteries, because the way they work is not all that different. So load the knowledge of lithium-ion batteries into your working memory, and we'll create some new connections to add sodium-ion batteries to your database.
Teach me.
A fully charged battery has its sodium ions packed into the anode. When you add a load between the electrodes, then electrons flow from the anode to the cathode, and the sodium ions follow shortly thereafter. As we mentioned earlier, you can't use a graphite anode like you can for lithium. The sodium ion is almost a third bigger, so you won't be able to recharge your battery too many times before it breaks down. Thus, you have to use disordered carbon or hard carbon to give the sodium ions a chance to intercalate. The cathode is something called the Prussian blue analog. That means something that is structurally similar to Prussian blue. Prussian blue was the first synthetic dye ever made, all the way back at the beginning of the 18th century. Its structural properties were a little hard to figure out, but when scientists finally did it, it turned out that it was perfect for accommodating ions. Speaking of perfect, let's check out the latest offering from today's sponsor, Omaze. Omaze is offering you the chance to win this $4.3 million Los Angeles dream house. A modern farmhouse designed 5 bedrooms, 6 bathrooms spread across 5,800 square feet. Pool, hot tub, sports court, and you also have the option of choosing a multi-million-dollar cash prize instead of the house. Even better, if you register between January 17th and February 2nd, you will automatically be entered in for a chance to win the Tesla Model Y. Your generosity supports Rebuilding Together, which is a charity organization in the US devoted to repairing the homes of veterans, people with disabilities, and neighbors with low income to help keep the communities intact. Their long-term projects include revitalizing entire neighborhoods by bringing together local volunteers and leaders to improve parks, schools, community centers, and non-profit facilities. Additionally, Rebuilding Together is instrumental in recovery efforts after natural disasters, helping residents rebuild their homes and lives. So a part of your contribution supports this cause. To potentially win your Los Angeles dream house and to support Rebuilding Together, go to omaze.com/techfulladites. You will find the link in the description below. So, you already know that salt is pretty ubiquitous. And salt is just sodium chloride. Sodium is far, far more readily available than lithium, accounting for 2.6% of the Earth's crust. And sodium-ion batteries don't need cobalt, which is one of the problem ingredients of lithium-ion batteries. As such, the cost of sodium-ion batteries is likely to be much lower than the alternatives, at least 20 to 30% cheaper in the short term, possibly getting as low as $30 per kilowatt hour in the future. Comparing that with lithium-ion batteries, which even with economies of scale are still over $100 per kilowatt hour. The case for sodium starts making sense. There is also the question of safety. The lithium batteries we use today use an organic electrolyte that is extremely flammable. Every year we hear some version of the same headline. Recalls, fires, lawsuits, the liability for which has to be baked into the cost of the battery. And these fires are much harder to put out because they don't need oxygen from the air. So often you just have to let them burn themselves out till the entirety of the electrolyte is consumed. Sodium-ion batteries don't suffer from such issues. You can shoot them, cut them, crush them, pierce them, and while you might notice a dip in performance, they will not catch fire. I think most people would be far more comfortable with this form of storage, especially when you're talking about grid or utility scales. They're also far easier to transport. You can deplete the charge in a sodium-ion battery to zero without damaging the battery. If there is no energy stored, the chance of an accident goes to near zero. Lithium-ion batteries suffer problems when you take the charge too low. And that's why you always see them halfway or a third of the way charged when you receive a new device, to increase their shelf life. Don't worry, I'm not going to give this tech a smooth ride just because it's more environmentally friendly. There is this famous chart for batteries. You have 3 axes. Choose any 2. The lithium ion is much lighter than the sodium ion. So when all else is equal, the former will always give you a better performance in terms of energy stored per unit weight or specific energy. So prototype sodium-ion batteries have gone up to 160 kilowatt hours per kilogram, but most of them have lower performance as of now. That makes powering transportation a much harder problem. Lithium is 50% better and constantly improving. It has some way to go before it hits a theoretical limit. Even in terms of voltage, sodium-ion batteries fall behind, just because of where they both are in the periodic table. In both electronegativity and specific energy, lithium is king. And even the safety features touted earlier don't paint a complete picture. Sodium, the metal, is highly reactive. If it forms in any of the side reactions, your cell will be in trouble. The breakdown of the electrolyte has historically been a big problem for sodium-ion batteries. With batteries, it's safe to say that some of our content has been speculative. But with sodium-ion batteries, we're on very solid, very salty grounds. CATL, one of the largest battery manufacturers in the world, recently announced that it would start creating battery packs that incorporated both lithium-ion and sodium-ion cells in 2023. This is a company worth $200 billion. So their investment in this technology is a big push for the industry as a whole. Though most applications being talked about are in grid storage, the specific energy of sodium-ion batteries is competitive with LFP batteries, and those are increasingly being used in electric vehicles, especially in budget models. Everyone doesn't need 500 kilometers of range. So it's not completely implausible to think that this technology may have a say in mobility applications as well. And that's before you even consider the millions of lead-acid batteries that are out there. Everyone who has one of those could use better performance and energy density at the same price. Companies like Natron, Feradion, and Tiamat are also making progress and already have working products for different markets. Telecom towers, utilities, and data storage are all potential customers who will need stationary storage in the near future. So undoubtedly, there is room for significant growth. Lithium is a relatively scarce resource. I know there are people who say you can extract it from the ocean, but yeah, you can't extract resources at an arbitrary cost. Just because you can doesn't mean it'll be worth it. And cobalt and nickel supplies also currently put a limit on how fast an electricity-based economy can be built. In countries like India, for example, there are very limited lithium reserves, meaning that electric vehicles will be very expensive and out of the reach of the common man for the foreseeable future. Table salt has been accompanying man since time immemorial, adding flavor to food, preserving meat, sparking revolutions to killing leeches and binding elder demons. And a revolution in electric storage may not be possible without it. Will the companies working on it come through? Or will too much of it increase the Earth's blood pressure? So many mysteries. Anyway, that's it for this video. Thanks to our sponsor Omaze. You can click the link in the description below to enter for your chance to win. I'll see you really soon. Bye.